Today, we are going to be learning about natural deduction. Now, the key to natural deduction are two big ideas. The first big idea is to use the 16 rules that are given to you in lecture. Now, as you can see, we have a sample problem here, where we have this should conclude this. Now, how can we conclude not Q implies P? The first thing you should always do is look at how to get to our conclusion. One of the only ways we can actually get from not Q implies P is by using an implies introduction. And to start an implies introduction, we need to start by assuming not Q. Now, once we assume not Q, we need to somehow, in the same assumption box, conclude P. Now, that is step one. So after I've set up the framework to get the implies introduction, I need to use the second big idea, which is breaking down what am I given. Right now, that means breaking down our premise. And because our premise is connected by an OR, that means we should probably be doing an OR elimination to break it down into each of the individual parts. Let's do that. So we first start by assuming not P and Q. Now, let's apply the second big idea again and breaking down this original premise further to get us closer to what we want, which is to conclude P. And that would be pretty straightforward. We can just do another AND elimination to just straightforward and conclude P right there. So now that we've done half of our OR elimination, let's look at the other half. Not P and Q. Now, how can we get from not P and Q and somehow conclude P? If we look at what we are given, the only possible rule that allows us to go from an unrelated element, Q, and conclude another element, P, is using the false elimination, which means somehow we need to conclude false. Now, can we look at what we are given and somehow conclude a false? Well, to conclude a false, we need some sort of contradiction. At the beginning, we assume not Q, but by using an AND elimination, we can conclude a Q, which is a direct contradiction to our original assumption. Then we can conclude false, which then we can conclude a P, which means then we can wrap up our OR elimination and conclude P at the beginning. This is what our final product should look like.
So as you can see, we have a different problem here, and one thing you're going to notice is that this one actually has quantifiers on it. Now, whenever I have a problem with quantifiers, the way I like to look at it is just pretend that they don't exist for now, and I'll explain why later, but for now, let's just pretend that we have the premise, not P of X and Q of X should conclude P of X implies not Q of X. Now, knowing our conclusion that we want to achieve and the 16 rules that we are given, what should be our first step?
Since we conclude on step 9 with an implied statement, we want to start with an assumption of P of X not on line 3 inside an assumption box.
So now that we have our setup for our implies introduction, we somehow need to conclude not Q of X not. So knowing our two big ideas, how should we approach this?
Not really sure how to do this one.
Well, let's look at our conclusion. We need to get a not in front of a Q of X not. And the only way we can get a not in front of a predicate is by using a not introduction. How do we use a not introduction here?
So the not introduction says that in order to get to the not introduction, you have to start by assuming it to be true and somehow getting it to be false.
That's exactly right. So why don't we start by assuming Q of X not is true. Good. So now that we have our not introduction set up, all we need to do is somehow conclude false. Now, one thing we haven't done is use the premises that we are given. So what do you think our next step should be?
I think we need to use our premise, and in order to do that, we would have to use a for all in, and we would get not P of X not and Q of X not.
That's right. So we broke down our premise, and now what else can we do using what we assume and what our premises that we have given? What can we build to somehow reach a contradiction?
Now, I can see that we have a not P of X not and Q of X not, and we are also assuming from number 3 and number 4 that P of X not and Q of X not are true. So what we can do is we can use a AND introduction to get P of X not and Q of X not.
Exactly, and that's a direct contradiction, so what can we conclude?
Now, we can use a not elimination, and we can conclude false.
And now we've finally completed our not introduction. Perfect. Let's wrap this all up.
From step 9 to step 10, what happened to the quantifiers?
That's a good question. So if you remember, I said let's pretend the quantifiers don't exist at the beginning. And steps 3 through 8 are kind of doing the exact same proof, but when the quantifiers don't exist. That's because all of it is happening under the assumption of an arbitrary element x naught. And that means that once we conclude that the predicates are true for an arbitrary element x naught, we can conclude it is true for all elements x naught. And that's kind of what's happening here. We're taking an element and using it, plugging it into our predicates, concluding that it's true. And once we have this, we can finally introduce our for all quantifier, which is actually another one of the 16 rules that we were given.